Good day everyone, I am Josh B. Morales from NS1A4 and today I will be doing is how to solve the GCD. So here's the scenario. You are going to determine the waypoint to use along the great circle track from 35 degrees north, 7 degrees west to 39 degrees north, 74 degrees west. First, we will list the departure position. The departure position is latitude 1, 35 degrees north, and longitude 1 is 7 degrees west. And the arrival position is latitude 2, 39 degrees north, and the longitude 2, 74 degrees west. Before we compute, we always take note that the same name is minus and the different name is plus. If we minus the lat 1 and lat 2, the answer is the d lat is equals to 4 degrees north. If we minus the long 1 and the long 2, the answer is the d long is equals to 67 degrees west. The next is we will find the great circle distance. The formula for great circle distance is cos GCD is equals to open parenthesis cos lat 1 times cos lat 2 times cos d lo is close parenthesis plus or minus open parenthesis the sin lat 1 times sin lat 2 and close parenthesis. If we compute cos lat 1 35 degrees in calculator, the answer is 0.81915. The next is if we compute cos lat 2 39 degrees in calculator, the answer is 0.77715. Next is we will put the cos d lo is 67 degrees. If we compute in the calculator, the answer is 0.39073. Next is we will times these three, 0.81915 times 0.77715 times 0.39073, and the answer is 0.24874. The next step is we will solve the sin lat 1 times sin lat 2. Next is we will solve the sin lat 1 is 35 degrees. If we compute it in the calculator, the answer is 0.57358. The next is sin lat 2 is 39 degrees. If we compute in the calculator, the answer is 0.62932. The next is we will multiply 0.57358 to 0.62932 and the answer is 0.36097. The next is we will add 0.24874 to 0.36097. We use addition because we are not crossing the equator. Because the latitude 1 and the latitude 2 have the same name north, we will add 0.24874 plus 0.36097 and the answer is 0.60971. We are not done yet because we will compute in the calculator. We will put cos answer equals degrees and the answer is the distance angle is 52 degrees 25 and 53 and 27 minutes. And then we will divide it to 60 and the answer is 0.88 or 0.9. So we have the distance angle of 52 degrees 25.9 minutes. The next is here the formula for great circle distance is equals to distance angle times 60. So our distance angle is 52 degrees 25.9 times 60 and our GCD is 3145.9 nautical mile. The next is we will solve for our initial course. The formula for initial course is sin IC angle is equals to open parenthesis cos lat 2 times sin d lo close parenthesis and divided by sin distance angle. The next is cos lat 2 is equals to 39 degrees. We will compute it in the calculator and the answer is 0.77715. Then our sin d lo is 67 degrees. We will compute in the calculator. Then the answer is 0.92050. Next is we will multiply 0.77715 times 0.92050 and the answer is 0.71537. The next is we will look for our sin distance angle. Our sin distance angle is 52 degrees to 5.9 minutes and if we solve in the calculator, the answer is 0.79263. The next is we will divide 0.71537 divided by 0.79263 and the answer is 0.90253 nautical mile. The next is we will compute it in our calculator. We will put ship sin answer and equals. So our initial course angle is 64.493. The next is quadrant rule and we will look for the northwest in the quadrant rule. The formula is northwest is equals to 360 minus course angle is equals to true course. So northwest is equals to 360 minus 64.493 is equals to 295.507. So our initial course is 295.507. The next is we will solve for the final course. The formula for the final course is sin final course angle is equals to open parenthesis cos lot 1 times sin's dilo, close parenthesis, divide sin's distance angle. Next is we will compute the cos lot 1, which is 35 degrees. In the calculator, if we solve it, it is 0.81915. The next is sin dilo is 67 degrees. If we compute in the calculator, the answer is 0.92050. The next is we will multiply 0.81915 times 0.92050, and the answer is 0.75403. The next thing that we are going to do is to compute the sin's distance angle. The sin's distance angle is equals to 52 degrees to 5.9 minutes. The answer is 0.79263 if we can compute it in the calculator. The next is we will divide 0.75403 is divided to 0.79263. The answer is 0.95130 southwest. The next is we will compute in the calculator. We will put the ship and sin answer and equals, and the answer is the final course angle is equals to 72.045. So after getting the final course angle, we will go to the quadrant rule. For this quadrant rule, we are looking for the southwest. The formula is southwest is equals to 180 plus course angle is equals to true course. So southwest is equals to 180 plus 72.045 is equals to 252.045, and the final course is 252.045. The next is we will solve for the latitude vertex, and the formula for latitude vertex is cos lat vertex is equals to cos lat 1 times sin initial course angle. Our cos latitude 1 is equals to 35 degrees. If we compute it in the calculator, the answer is 0.81915. The next is sin initial course angle is equals to 64.493. If we compute it in the calculator, the answer is 0.90253. And then we will multiply 0.81915 times 0.90253, and the answer is 0.73931 north. Then next we will compute in the calculator. We will put ship cos answer and equivalent is equals to, so our latitude vertex is equals to 42 degrees 19 and 38.38 minutes, and then we will divide it to 60, and the answer is 0.6, and our latitude vertex is 42 degrees 19.6 minutes. The next is we will compute the difference longitude vertex. The formula is sin's dilo vertex is equals to cos IC angle divide sin's latitude vertex. So the next is cos initial angle is equals to 64.493. If we compute in the calculator, the answer is 0.43062. The next is sin lat vertex is equals to 42 degrees 19.6 minutes. If we compute in the calculator, the answer is 0.67336. The next is we will divide 0.43062 divided by 0.67336, and the answer is 0.63951 west. The next is we will compute in the calculator. We will put ship, sin answer, and equivalent to our difference longitude vertex is equal to 39 degrees 45 and 19.05 minutes. And next we will divide 19.05 minutes divided to 60 is equals to 0.3, and our difference longitude vertex is equals to 39 degrees 45.3 minutes. So now we will track the great circle in every 10 degrees. The first thing we need to do is to write the departure position, which is our latitude 0 is 35 degrees north and the longitude is 7 degrees west. The next is we will write the arrival position, which is the latitude 8 is 39 degrees north and the longitude is 74 degrees west. So now we will track the great circle in every 10 degrees. As you can see in our longitude, 7 degrees west, and we will put 10 degrees west, 20 degrees west, 30 degrees west, 40 degrees west, 50 degrees west, 60 degrees west, and 70 degrees west, until we reach the arrival position, which is longitude of 74 degrees west. And now I will teach you how to solve the latitude 1, which is 36 degrees 07.2 north. And we will compute the latitude 1, and first we will need longitude 0, which is 7 degrees west. It is constant. The next is the longitude 1 is equals to 10 degrees west. Always take note that if it is the same name, we will minus it, and if it's the different name, we will plus it. So this is both west, same name, we will minus it, and the answer is 3 degrees west. The next is the dilo vertex that we have solved a while ago. is the DLO vertex is 39 degrees 45.3 west, and this is constant. And we are going to minus it because they are both same west, same name, so we will minus it. So our DLO vertex is equals to 36 degrees 45.3 west. After we get the DLO vertex, we will perform this formula: tan lat times is equals to cos DLO V vertex times tan lat V. So our cos DLO vertex is 36 degrees 45.3 minutes. If we compute in the calculator, the answer is 0.80120. And then tan latitude is constant, and the tan latitude is 42 degrees 19.6 minutes. If we compute in the calculator, the answer is 0.91078. And then we will multiply 0.80120 times 0.91078, and the answer is 0.72972. Then next we will compute in the calculator. We will put ship tan answer equals, and the answer is the latitude 1 is equivalent to 36 degrees 07 and 8.32 minutes. And we will divide 8.32 divided by 60 is equals to 0.2. So our latitude 1 is 36 degrees 7.2 north, and we are successfully solved the latitude 1. And now I will be showing you another example on how to get the latitude 2, 39 degrees 7.2 north. Here is the latitude 2. We will put the long 0, which is 7 degrees west. It is constant. The next is we will use the longitude 2, which is 20 degrees west. So the long 0 and long 2 is both west, same name, we will minus it. And the answer is 13 degrees west. This is the DLO. And next we will solve the DLO vertex. The DLO vertex is 39 degrees 45.3 west. This is constant. And the DLO vertex is both west, we will minus it. If we minus it, we get the DLO vertex 26 degrees 45.3 minutes west. The next is we will perform this formula: the tan lat x is equals to cos DLO vertex times tan lat v. Next is the cos DLO vertex is 26 degrees 45.3. If we compute it in the calculator, the answer is 0.89294. The next is tan lat vertex is equals to 42 degrees 19.6. If we compute in the calculator, the answer is 0.91078. Then we will times 0.89294 times 0.91078, and the answer is 0.81327. Then we will compute in the calculator. We will ship tan answer, and it equals to our latitude 2 is equals to 39 degrees 7 and 13.76 minutes. Then we will divide 13.76 divided by 60, and the answer is 0.2. And then our latitude 2 is 39 degrees 7.2 minutes north. So we are successfully compute the latitude 1 and the latitude 2, and you need to fill it until the arrival position. And now I will teach you how to solve the course 295 and the distance 161.43. And now we will compute the course 1 and the distance 1. The latitude 0 is 35 degrees north, and the latitude 1 is 36 degrees 7.2 north. We are going to minus these two. Because the latitude 0 and the latitude 1 is both north, we will use same name minus. We will minus it, and the DLAT is equals to 1 degree 7.2 minutes north. And then we will times it to 60, and this is constant. And our DLAT is 67 degrees 12 minutes or 67.2 minutes north. Next is we will use the longitude 0, which is 7 degrees west, and the longitude 1, which is 10 degrees west. Because our longitude 0 and longitude 1 is both west, we will use same name minus, and the answer is 3 degrees west. Then we will times it to 60. 60 is constant. Then our D long is 180 minutes west. Then next we will be solving for the MP is equals to log, open parenthesis tan, open parenthesis lat, divided by 2 plus 45, and double close parenthesis times 7915.7 minus open parenthesis 23.3 times sin, open parenthesis lat, plus double close parenthesis. How to get the MP1 in lat 0 is we will insert the lat 0 in the MP formula, and then the MP1 is equals to 2230.92. And also the latitude 1, we will insert it in the MP formula, then the MP2 is equals to 2313.16. They are both north, so the same name minus, and the DMP is equals to 82.24. The next is we will compute the true course. The true course formula is DLO divided by DMP, the DLO is 180 and the DMP is 82.24 and the tan course angle is 2.18872 and the course angle is 65.44 northwest. The next is we will solve the quadrant rule. The quadrant rule formula is northwest is equals to 360 minus course angle is equals to true course. And the northwest is equals to 360 minus 65.44 is equals to 294.56 or 295. And our true course is 295. The next is we will solve the distance. The distance formula is distance is equals to DLAT divided by cos course angle. The DLAT is 67.2 and the course angle is 65.4. If we divide it, the distance is 161.43 or 161.4 nautical mile. So now I successfully show you how to get the course 1 to 95 and the distance 1 is 161.43 nautical mile. So I will give you another example to how to get the course to 291 and the distance is 509.2. So we will compute the course 2 and the distance 2. We need the latitude 1 which is 36 degrees 7.2 minutes north and the latitude 2 is 39 degrees 7.2 minutes north. The latitude 1 and the latitude 2 is both north, same name, we will minus it. Then the answer is 3 degrees minutes north. We will times it to 60. So our DLAT is 180 minutes north. Then next we will be solving for the MP is equals to log open parenthesis tan open parenthesis lat divided by 2 plus 45 and double close parenthesis times 7915.7 minus open parenthesis 23.3 times sin open parenthesis lat plus double close parenthesis. We will insert the lat 1 in the MP formula. So the MP1 is equals to 2313.16 and the latitude 2 we will insert it in the MP formula and the MP2 is equals to 2539.50 because they are both north, same name, minus, so the DMP is 226.34. And now we will solve for the D long and we will put the long one which is 10 degrees west and the long 2 is 20 degrees west and we will use the minus because they are both west. The D long is 10 degrees west and we will times it to 60. So our D long is 600 minutes west. The next is we will solve the true course and the true course formula is DLO divided by DMP. So the DLO is 600 and the DMP is 226.34. So the tan course angle is 2.65088. Then we will compute in the calculator. We will ship tan answer and equals and the course angle is 69.33 northwest. The next is we will solve for the quadrant rule and the formula for the quadrant rule is the northwest is equals to 360 minus course angle is equals to true course. So the northwest is equals to 360 minus 69.33 is equals to 290.7 or 291. So our true course is 291. The next is we will solve the distance and the distance formula is distance is equals to DLAT divided by cos square angle and the DLAT is 180 and our course angle is 69.33 and our distance is equals to 509.2 nautical mile. And now we are successfully solved the course 1 and the course 2 and the distance 1 and the distance 2. So you need to continue it until you fill the rows. Lastly, we need to add all the distance in 161.43 plus 509.2 plus 499.5 plus 420.8 plus 439.3 plus 452.8 plus 467.5 plus 194.3 and the total distance is 3144.8.
Thank you for listening in. I hope you learned something.